have our esteemed leaders from yesterday up here, and we are so glad to hear about how day one went. I think we're really excited to hear that. So I will introduce, we have Lisa Brenner with the VA Rocky Mountain Mental Health Research Education and Clinical Center. We have Doug Smith. I'm not going in order here, I apologize. We have Doug Smith with the University of Pennsylvania. We figured it out. We have Elisabeth Wilde with the University of Utah, and I'm sorry we had your Baylor affiliation on there. And additionally, we've had a change. We have Mary Jo Pugh, and she's also with the University of Utah and Salt Lake City VA. So thank you all for being here today. And Doug, are you going to kick us off, I think? Sure. Wonderful.
So we want this sort of purposely sitting to be interactive. We don't want to have like didactic, blah, blah, blah from the lectern just describing what we've done. And one thing we wanted to point out, I think that had a commonality across all the groups, is that there's a problem with harmonization in general. And in particular, I would say that in our case for the preclinical modeling, we were talking for the entire time, debating until at the end we really kind of came together and said, really everything falls under one umbrella. I think Pat Kohanic pointed out that we've kind of hit a different time. At some point, mild traumatic brain injury or concussion became a focus, and yet all the preclinical researchers were left with the same old models they've been using for years. And we'd see models with a contusion that would somebody say this is mild TBI, and based on maybe behavioral outcome, and it just is taking a while for the field to kind of catch up. So the feeling of the group in general was that why don't we try to harmonize something we know clinically about concussion and make sure that the preclinical models match that, and that might be the area you study, rather than just declaring your model mild. And I think that as an umbrella concept really took up almost all of our discussion. There's also a point, any questions about that? There's also interest in more chronic studies because that's really what we're talking about. So about 20% of patients with concussion are just sent out from the ED or they see the primary care out into the wind to diagnose that they have chronic or persisting symptoms over time. And they really don't know what to do, or there's no really great therapies in that chronic state. There are some emerging. So this is a really underserved area that we thought was also important to look at. And again, harmonizing the preclinical models with the clinical cases. There's also a lot of discussion about how people might be just repeating studies over and over again because they aren't making the data public, which is kind of tough with negative data. So just how can we, as a gap, how do we think of where the negative data will go so people can actually take a look at it? And then there was a kind of a soup to nuts, so have multiple species, whether they're lissencephalic or gyrencephalic, and maybe even work up the food chain, so to speak, so that, whereas a pig model of rotational acceleration may replicate many aspects of concussion, but you can't do large-scale studies in high throughput, so you have to find a way to harmonize that with another model. So, it's not just the models have to be relevant clinically, they have to be relevant to each other. And then we thought it would be very important to look at what people are bringing to the table before they have an injury, and see if we can have the animal models replicate that or mimic that in some way, so that it's not just a healthy young male rat that we're looking at to tell us about human females or older folks. So that's kind of it for our group. Those are the main points. And do we want to talk about each section at a time, do you think? Yeah, so any questions?
I was wondering, did the group consider establishing any criteria for validity of these animal models? What constitutes translational validity and utility for the purpose that?
Yeah, so the goal was really kind of to identify gaps, but things were brought up. For example, there's only one study on human neuropathology and concussion from 1994 where there were 6 mostly older individuals who died within a few days, mostly from pneumonia. And the diagnosis was diffuse axonal injury. And that could be true, and many of us believe that that's one of the most likely underlying neuropathologies. But those folks, that could have really been from hypoxic ischemia at the time of death. So we have to kind of rely on more non-invasive measures where we have advanced neuroimaging telling us things that maybe there's white matter changes or blood biomarkers that show us either axonal proteins or other concepts of the other components of the brain. If those proteins are in the blood, does that mean there was degeneration? We also have other there's a lot of measures, electrophysiological and whatnot, that might be able to be used to calibrate the preclinical models with the clinical models. In fact, I think that most people who do neuroimaging think there is diffuse axonal injury, but what is that? So maybe that 20% who go on with persisting symptoms has more of a degenerative diffuse axonal injury. Maybe having diffuse axonal injury for most people is completely reversible, just might be an ionic imbalance or whatever, so that that they can just go back and recover. But to 20%, if we see axonal proteins in their blood, that's akin to having troponin in the blood telling you about your heart being damaged. Axons don't grow back, so that we can infer something about the human condition in the animal models as long as we have other ways to calibrate it. Ramon?
Those of us who've been thinking about this from the clinical side have really been trying to get away from the nosology of mild, moderate, and severe. We just don't find it to be very helpful. And it's mainly because, as we all know, right, someone who looks mild by all possible criteria 3 or 6 months later has a very disabling condition to that is just not fair to call it mild. On the other hand, the reverse also happens, right? Someone who looks very severe early on sometimes make very favorable recoveries, right? So I think maybe one thing we've been trying to do on the clinical side, and I think you as well on the preclinical side, is focus more on different pathophysiologies, right? Are you studying axonal injury? Are you studying inflammation? Are you studying focal contusion, which is not irrelevant, right? Are you studying vascular injury, et cetera? And obviously different models may emphasize one or the other. Probably not all models are going to have the entire complexity of human TBI, but that's okay because we can then identify each of these endophenotypes and develop therapies and develop biomarkers for each one.
Yeah, I knew you weren't going to get out of it without saying endophenotype, but
It's a great word.
We did not discuss how to bring in the nomenclature police to help us with these wording. I think we're kind of stuck with concussion, and then maybe rather than trying to get everybody to reorientate to different words and how you categorize things, exactly what you're saying, just talk about the underlying neuropathology. So we think blood-brain barrier is important, or inflammation is important. As long as that's the target and not this non-diagnostic word of concussion, which has almost no diagnostic meaning, it's an opinion. You've looked at people with pretty large matter changes in CT with GCS of 15, or perfectly normal, versus other individuals, normal brain, who are impaired. So we really need to get away from these terms, but I think until the nomenclature police really come in and help us out, we're kind of stuck.
But we need to be, I'm not sure nomenclature police is the right term, but we need to inform everyone else, right? The stroke specialists who review our grants are in ANI and BINP, right? We need to inform them somehow. Maybe this is the right mechanism, right? That we really don't think this mild, moderate, and severe thing is really that useful, and it's going to get us to the next breakthrough in therapies.
Yeah, I tell people that they used to say, call it diabetes, that just means, water passing through, until they discovered what it is. And they kept the word. Whereas with consumption, nobody knew what that was until they found the bacteria in the late 1800s, and then they had a target that they can treat. So we should follow those kind of, either we can keep the term concussion or maybe split it into degenerative something or other, but we do have to work towards words that describe the underlying neuropathology and not just this symptom type of description, opinion. Yeah.
because we're recording. I want to make sure we do capture. So related to the notion of really pursuing the pathology and describing that, was there any discussion about having a deeper assessment of the animals themselves? I know a lot of the models look at cognitive endpoints and so on, but and now you're talking about molecular and imaging endpoints. What about sleep? What about other domains that could be evaluated that definitely translate and maybe can be readily picked up through an EEG approach?
Oh, absolutely. So as you heard Pat Belgowan talking yesterday, that what if we can develop the same type of outcome measures in humans and animals, and we did talk about EEG and other measures, and maybe even imaging, and if we find a way to harmonize that between animals and humans, then that will, and there are also CDEs, and that would be one excellent way to try to compare apples with apples and not just say declare your model mild and then make conclusions that may not come out in the real world. Yeah, that's a good point. Anybody else from our group want to? No.
Oh, thank you.
Yes, I'm a relative outsider of this field, but I feel that one of the biggest barriers or gaps in preclinical and translational research actually starts with the lack of granularity we have in defining the clinical phenotypes. So if we talk about migraine, what is that exactly? How do you find it, and how can you measure it objectively in a high degree of granularity? And can we then translate that back to the clinical models? So just the clinical phenotypes, I think, could be more defined in a more granular level.
Yeah, we actually talked about headache, which is one of the most common symptoms, and that is a challenge. So there's some things that may be more of a challenge than others. But if we already have techniques that do translate, let's say, electrophysiology or imaging or whatever, or biomarkers, then we have the ability to then coordinate it. Headache, that's a problem, but we have to, go to where we can for right now.
Okay, so many of the general concepts and issues that were brought up yesterday in the talks we discussed, but kind of at a level that was specific to either fluid biomarkers or neuroimaging or physiologic biomarkers. So the first one that came up for us was just the need to really pay attention to both the timing of the markers that we're looking at, so both in terms of fluid biomarkers or neuroimaging biomarkers, but to take a look at differences that are occurring in both the pattern and the magnitude over the course of recovery, and to really kind of make those more specific to what we're looking at. The second was related to data harmonization and standardization. Again, so this will probably be a somewhat common theme. For example, in imaging, we have an issue where the data that we derive from different magnets or different vendors is different. And so although there have been some great strides toward making those more similar in terms of acquisition protocol standardization, there are still additional things that we can do on the back end in terms of post-processing that we can enhance that harmonization even further. And so I think it is an area of great development in imaging, but it requires a bit more work. We're still not quite there yet. And I think similar things could be said about fluid biomarkers and electrophysiological biomarkers as well. There's a need to really integrate modalities within both the same patient populations and the same time points. I think some of these larger consortiums in TBI have done a great job of providing large amounts of data that can integrate a number of these different modalities, but there still is a lot we need to learn because oftentimes in smaller studies we will we'll have data from just biomarkers or certain biomarkers, or we'll have data from imaging, or we'll have data from cognitive outcome or things like that, but it's difficult to integrate all of them at the same point, which is something that's really necessary for the next point, which is to kind of identify and integrate multiple, or identify constellations of these biomarkers that are important. to target very specific symptom presentations or very specific patient populations. So Jessica, is there anything you would want to add to that? No, I think that's good. Any questions or comments? Sina?
With regard to the time, I'm aware, of course, that in clinical studies, you cannot always have the same time point. And even in preclinical models, it is possible to integrate the time in the mathematical algorithms and control for it so that you can actually do the same correlations with outcome while time is controlled for, to take that part of the noise out of the heterogeneity of the whole spectrum of TBI. So I think even though it would be desirable to have the same time points, you can make good prediction of outcome if MRI is at another day than the blood biomarkers, if you have a good concept integrated mathematically, for instance.
Yeah, I just have sort of two comments about that. The first is that I think that's one of the really challenging things about designing studies is that oftentimes we're trying to look at multiple elements, but we know that the resolution of these markers are different, and so it's difficult to pick the exact time points because it depends a lot on the question that you're trying to ask, and you're kind of limited by, precisely what you're trying to get at. So I think it's a challenging thing to do. And then I think one of the things that I'm hoping we're going to talk about this afternoon is ways that we can integrate with much more sophisticated mathematics or modeling than simply looking at sort of linear relationships with time as a variable, because these relationships are not at all linear. And we need to incorporate that dimension in a much more sophisticated way, particularly when we're trying to utilize large amounts of data that are, that are different and disparate.
So I was in the session, but with respect to the first issue of timing, I have two questions related to that. The first is, I've heard today a lot of people talk about kind of the vagueness of the injury, especially for certain injuries, and we talked a little bit about that for, blast injury and things of that nature. How accurate is can a person's recall be of the actual injury so that we can actually get that fine granularity of timing if we're relying on self-reportive recall? And then secondly, if we want to get people closer to the injury status, are there, and I asked this, I don't know the answer to this, are there barriers right now from a research perspective, from an informed consent perspective or whatever, in kind of getting people participants very soon after an injury occurs?
Okay, so two different questions. So the first question is related to kind of the self-report of injury and kind of what they can recall about that. So that depends, I think, a little bit on the severity of the injury, right? So with people who have never lost consciousness, sometimes it's a little bit more accurate, although often there's an alteration of consciousness or kind of a dazed phenomenon where it's a little bit, even in the best case scenario, it would be a little bit difficult from a physiological perspective to sort of to have accurate memory about that. But if you add to that other situations, so for example, in military populations, if you've got fog of war situations, that intensifies it even further. We know that our perception of the passage of time is probably not really accurate even in good circumstances. But in circumstances like that, it's even more challenged. The estimations of longer terms or longer loss of consciousness is usually a little bit better, but not from the patient themselves. It's it's usually better documented in medical records and things like that. And then the second question, remind me what that was again.
Barriers in recruiting people within acute points of the injury.
Right. So the barriers for that often are, at least in my own experience, have just been really the situation of the particular ER. So, or if you're recruiting from ER, or on the field, if you're recruiting on the field, it's a little bit different. And the specific location or the specific culture around that's happening kind of sometimes makes a big difference in how that's able to be done. But the biggest barriers that we've sort of found, at least in things like emergency room recruiting, is really just related to you have patients who are there, they're uncomfortable, they're waiting for procedures, or sometimes they're, it depends on sort of the efficiency of the emergency department, how quickly you're able to do that. There have been a number of studies, that have been able to recruit patients within 24 hours and even do pretty sophisticated imaging and biomarker collection and cognitive outcome. So it's certainly possible. It's challenging. It requires, a number of people who can be in the ER recruiting and people who can very quickly get people into a scanner or be there to collect blood. So it's certainly not inexpensive to do, and it takes a lot of effort, but I think it can be done, has been done.
So I was in the session for the first half, and what I was struck by as you walked through each of the different diagnostic approaches is the fact that, of course, every single one of them has an obvious limitation in sensitivity or specificity, and that they differ, of course, by modality. But that there is a next generation of experimental approaches that have promise, and I would have thought that you would highlight the desire to invest in and getting those to what is it going to take to get them from where they are now to a place where they can be utilized in a clinical setting. And I'm wondering if you can comment on where you see what needs to be done.
Yeah, so imaging is a field where there's a lot, it's very rapidly evolving. So there are new techniques pretty much every month, or maybe not quite that often, but, and the ones that exist evolve very quickly. And so I do think that there is always this promise with a lot of things that are coming up. And I think particularly lately, there have been a lot of modalities that are very specific to a pathology, which we really like, because they're part of the problem with some of the ones that have been in existence longer is just they're sensitive, but they're not very specific to a certain pathology. And so to match up things like, for example, TSPO ligands in PET or CVR to look at vasculature, that's really appealing. I do think we always have to be a little bit careful to remember that there is a pattern in imaging, that we always think that there's going to be one modality that's going to solve all of our problems, and it's going to sort of be the magic bullet. And it has disappointed us again and again and again. And so I think we need to sort of remember that as we're approaching this in the field, that we absolutely should explore these additional modalities, and that we should refine them, and that we should make every effort possible to overcome the gaps that prevent us from utilizing them clinically. But at the same time, I think we always need to have sort of a guarded optimism about how these things can really be applied and how useful they'll be, because although these things often demonstrate enormous promise in small studies, we find that as we try to apply them to individual people, it's challenging, right? Because not everybody is going to have the same magnitude of finding, and everybody's coming with a context. And so I think we just kind of need to remember that. But that's what I would say, is that these things are terrific. And of course I'm an imager, so I love imaging modalities. But I think we have to just be sort of careful in how we approach developing them.
So Lisa, I'm just on that point. So in thinking about the harmonizing preclinical models with the clinical circumstances, I didn't really see the word diagnosis here. So when you were saying that it's something that might be, whether it's a blood biomarker or imaging, diagnosing a underlying pathology, would that be one of the primary goals, kind of like a troponin or?
Yes. Yes. And I think that's the way the field is sort of trying to move. But again, I think we're sort of in a stage where we spent a fair amount of time yesterday discussing the diagnostic and prognostic kind of state of the science of imaging, and it's both, and also biomarkers, and it's pretty limited.
Well, I mean, I see people
use
DTI, and one person just says abnormal white matter changes, and somebody else will say diffuse axonal injury. So it's kind of in a flux right now.
Is there anybody else who is participating in our group who would want to sort of address any of these points? Yeah, Kim.
So I wanted to address your one question, and that is the major barriers. And that one thing from the operational perspective, or looking at especially subconcussive injuries in the military, the way to do it is during training. So the people that jump out of airplanes, the people who learn how to shoot Carl Gustavs. And so a big barrier is you have to work with the line operational forces. But if we look at the DV-BIC numbers, that's where our injuries, the majority, occur. And so I think that is a huge barrier. I think they are coming around to allowing people in. But you have, just as you're limited with the timing of data acquisition, you have to kind of enter seamlessly and not interfere with what they're doing. So that's actually a big barrier to research.
Can I also just, in terms of Reggie, for the measurement and the identification, I mean, there are folks that have spent a good chunk of their careers trying to figure this out. I'd say John Corrigan is one, working on sensitivity and specificity of measures, working on using, in particular, his is the OSU or the Ohio State University TBI ID, looking at self-report versus hospital medical records. And so, I mean, this dilemma is very well known in the field, and there are efforts around measure development that are worth looking into and seeing. There are some things that are better than others.
Hi, Stu Hoffman from VA. Lisa, I was thinking along the same lines. My question is a little bit, I mentioned this yesterday during the session, that when you're looking for these biomarkers and other indicators of injury, you got to take their life history, like John Corrigan's, but you're damaging the organ that is responsible for remembering those events. So recollection may not be always there. And I mentioned a couple people yesterday, you need almost a risk history of that person, taking together their geographical, where they grew up geographically, their socioeconomic level, and what sports they participated in, even before they went into the military, and what was their MOS. You have lifetime risk assessment, almost actuarial science, to get that background, to give some sort of perspective to any biomarker development that's going on. Because you might have a biomarker that's sensitive to injuries at different time points, but this person may have a history of 3 or 4 concussions before the one that you're now going to test out this biomarker on.
And I mean, just on this, we are, hopefully it's been accepted. We've got a paper coming out. We looked at individuals at Fort Carson now some time ago, and individuals who screened negative and positive right when they returned during a PDHA. And interestingly, you know, the vast majority of individuals who did screen negative for having a TBI in that deployment had a history of multiple TBIs prior. And so, you know, this idea that like, and then of course the group that was positive on that time also had a history of multiple TBIs prior. Surprisingly, some percentage of those, and we keep finding this, we found this in VA too, folks have moderate to severe TBIs prior to being in the military and then have been deployed. So sometimes we get asked questions, well, you know, why if you have 1 mild TBI is this person having so much trouble? Well, actually it may not just be 1 mild TBI. This might be their 3rd, 4th, 5th mild TBI, or actually it might be their 2nd, 3rd mild TBI and they actually had a moderate to severe TBI when they were a kid. So how do we start to highlight that and really understand that in the context of all the different ways we're trying to measure things?
But, you know, maybe the biomarkers can find that. So we're actually looking at some of the blood from the Carl Gustav training. And some people come with biomarkers that are elevated before they start training. So, I mean, maybe that's a way you have to even get it extra early, have the pre-deployment type of numbers available. Yeah.
Yeah. So actually yesterday we talked about all different categories of biomarkers. We covered all kinds of categories of biomarkers, but I don't know that well, I guess you did sort of talk about a biomarker of trauma load.
Yeah.
I don't know that we explicitly discussed that.
Yeah, that's a tough one. Yes.
We ready? Yep. Okay. In patient phenotyping, we had a very interesting discussion, and I think the majority of the time we spent talking about really what is a phenotype and how should we measure it. And there were some diverse thoughts. Is it best to just take a clinical perspective? And we have these clinical buckets that are very large, very vague, and we phenotype the head injury based on, you know, kind of symptoms initially, cognitive, headache, oculomotor, vestibular, Or should we take a more data-driven, so that was an a priori clinical approach without looking at data or other things, just from clinical perspective? Or should you take data and look at these phenotypes from a data-driven approach? And so I actually don't think we came to a good conclusion. I think that really one of the biggest gaps is that we don't have consensus in the field on how to best phenotype. And so I would argue that everything that we say here is based on that major gap. And I do think that some of the discussion that we just had, and we had this part of this discussion too, is that it's not just that head injury that happens, that you're phenotyping, it's their background, and it's really a lot of the things that Stu was talking about, but what's their prior head injury history? What kind of exposures have they had that may affect the impact of head injury on the physiological and psychological and emotional component of the person? And so we need a lot more data when we're phenotyping, I think is kind of the perspective that our group, it was the latent variable that emerged, is we need more data and we need to incorporate more data. But I do think it would be helpful, honestly, to have some kind of a consensus panel to come together from diverse realms to help figure out what is it that, and honestly, I think it should be a multidisciplinary group, and figure out what is it that we need to phenotype in data that's readily available, because we have these electronic health systems that you could use those data. If you could incorporate some physiological data, I don't know the feasibility of it, but I think we could get a group together and figure out what are the minimal data sets that you would need to do a reasonable phenotyping on populations. So what we do need are clinically rich data to characterize patients from acute to chronic. So some of the phenotyping that's been done is focused more on biomarkers and maybe headache. We have these big kind of clinical phenotyping a priority buckets, and then we have other phenotype studies that have looked more at chronic sequela. So I think we need an acute to chronic phenotyping that accounts for baseline. But we need clinically rich patient data on which to do that. And we actually, our group actually also thought it's important to get patient prioritized symptoms and outcomes in those phenotypes. We need the patient voice in that consensus panel. And we need big data to develop these clusters, because if you have little pockets of little samples here and there, you're going to get a different variety of phenotypes than you would if you have a population base. And why do we need that? Is because in Dallas, I think, expressed this the most clearly of anybody. So we have these negative TBI trials. Is it that the treatments aren't working? Or is it we have an enormous homogeneous population on which a small portion of these trials are effective, but the signal is too weak to come out because we're looking at a population, not a sample of people for whom it's relevant. We need longitudinal analysis. And I think the question, and this is related to what kind of patient clusters do we see, and do they change over time? So the whole acute to chronic theme is important in phenotyping. And we discussed a bit about, we don't know what kind of treatments people are doing. And then when you think about that, it's important for phenotypes, because if we know what kind of care is happening broadly, and you can phenotype, then you can determine within those phenotypes, are there specific kinds of care that are leading to better outcomes for certain individuals. And you can do some comparative effectiveness analyses with the big data to kind of drill down. But in order to do that, you have to have the phenotypes and you have to know what kind of treatments are happening. So, and then you can educate, and that will be helpful for implementation. So that's our implementation piece. So what's the current treatment? Do treatments vary? For whom do they vary? Why do they vary? And are some more effective for certain people and for whom? And there was a thought that we need an easy, quick, highly dispersed screening tool for concussion. I think that everybody would love. I don't know how feasible that is. These are lofty goals. So, not sure how feasible, but you know what? Let's think about it and let's make it happen.
Who wouldn't like that?
There's the optimist, the pessimist, and the awesomist, right? The awesomist, I wish I had my slide, sees the dragon in the glass of half empty / half full water. So I'm an unrealistic optimist or an awesomist. So, and And then we are lacking evidence for clinical measures that relate assessments to specific phenotypes for clinical trials. And really, this is the goal of this whole phenotyping effort, I think. I think we have two goals. We have clinical treatment, and then we have clinical trials, right? You want to type the kinds of people for whom the best treatments work, but in order to do that, you have to have the clinical trials to identify those treatments. So that is, I think, the summary of our group. Any questions, thoughts, or any input from others? Yep.
I guess a comment and a question, because if you look at biomarker development in the acute stage of an injury or disease, it's clearly tremendously highly relevant.
Yep.
But then again, how do you use these biomarkers down the road in the more chronic stage? Let me give you two examples. I have been diagnosed as having prediabetes. I've had that condition for 25 years. Every year, twice a year, I go in and get my blood taken, and about 50 things get printed out. I go to the doctor with this, say, okay, your A1C is fine, you can go. So here are these 50 different things that are taken. There's a charge for each and every one of them in the clinic, and nothing ever gets done with it, especially over time. Mm-hmm. Just recently, a member of my family went to the memory clinic, had an MRI, had blood work done, and a number of biomarkers were evidenced both in the imaging and in the blood. And they said, here, we have all these biomarkers. We can't tell you anything about this. This is not going to have any benefit whatsoever to you other than treatment, but would you like to have an additional spinal tap so that we can get more biomarkers? I'm not kidding. And so the big issue is, what do you do with this down the road? And how do you work with patients? And what does it mean to them? And how do you explain? You get 50 things printed out from your blood, and I mean it's about 40, 50 things, and only one counts that says, well, now you're A1C, and you get your 7 minutes, and you're thrown out of the office. So what then is the question.
That's kind of a biomarker question.
I do think we need to have I do think we need the basic science, the biomarker, and the clinical trial to be together in the phenotyping effort. But I love the question, because
it's a good question.
Should we be following those longitudinally, and do we see patterns? But that's a biomarker question.
And I also think it's actually a question about, I mean, I think this comes up several times about what is meaningful to patients.
Yes. Yeah.
And I think we're always much clearer about that when we're the patients or our family members are the patients.
Yep.
And sometimes, myself included, it's harder to keep track of that when I'm the researcher.
Yep.
So how do we as researchers keep track of what actually really matters to patients and families, what's actually going to really help patients and families, and then what is more maybe scientifically interesting?
So I was at the section here. So there's a tension between the people that want to define the phenotypes by data and the people that see patients clinically. So what we're seeing up here is a little bit of a tension between it's sort of a data-driven phenotypes versus what the clinicians see in these patients. And you can combine the two. What we're trying to do in the phenotypes is to say, this is what we see in the clinic. These are the things that people complain about. And they're important because you can treat them. So a lot of these patients have vestibular problems, oculomotor problems, they have migraine, fatigue, and so on. By identifying those things, right now they just say you have a headache, you have a concussion, go in a dark room. But by the way, we brought that up too. This whole issue, right now we have another disease called concussion treatment, which is producing a whole big problem in itself. We might look at that from a data point of view. But I think we should talk about this. There's a tension in our group when yesterday we met, where people said, let's step back, let's just collect a lot of data and then group people, and then from that grouping, we'll get the question, the answer together, sort of big data kind of thing, approach. As opposed to getting clinicians together and saying, what do you see in these patients and what can we treat? Let's start from there as the phenotypes and then see if it's connected to all the great biomarkers, imaging, and so on. Start from what we see clinically. You could say, no, we're not going to do that. We just want to collect data and we'll
Or you could do both.
You could do both. And I think, what we're finding, we're living in a really great age, and I'll say I see patients all the time, and And I actually have a clinic that I hold very strongly. The people that work with me are like, you're insane. Why do you spend half a Friday seeing patients? And it's for this exact reason. So there's things that computers do really well, and there's things that people do really well. And what we should be doing is combining those so that we have the strength of what people do really well and what computers do really well. Because I know I have my biases. I tend to see, perhaps whether I want to or not, same patterns over and over. So how can I get the smartest people I know together, like the people in this room, and then get the smartest programmers I know together, right, and data scientists together, and then
but you're
combine.
not telling us what you see from day to day. We're hearing about biomarkers and imaging.
I will. I'm happy to talk about it.
Okay, thank you.
I can't see.
Okay. So I was in the phenotyping group, and I did experience the tension, but I thought it was actually a very healthy thing.
Yep.
And I wanted to add something from the PTSD realm, which is more of my background than TBI, because they struggle with many of the same issues, which is how do you characterize somebody, and what do you do with both preclinical and clinical models where the event or incident is exogenous or acquired, as opposed to, but also has iterative characteristics. And PTSD is still struggling with that, but two of the things that they have made some progress on in predicting who does well in what kinds of treatments were mentioned here today. Stuart mentioned a couple, other people have mentioned some. One is the idea of trauma load, which we've now, each of you has mentioned in your groups has come up. And the other one is the variable of time, longevity, whatever we want to call it, time since the duration, the time since incident. And I think that hasn't been characterized well. And I was very struck by it coming up in our group where we had a number of clinicians who spoke to the fact that TBI patients get seen in all kinds of settings, then thrown back out into the wind, and then they may or may not come back in from studies, but they're very different populations as a result. They may be seen by a PCP, a pediatrician, an ER doc, on the field, no one. And we're assuming that all these people have something in common, but maybe one of the variables we have to put in as a potential marker is time since incident along with trauma load.
And I do think that has been a challenge in VA, outside VA, and PTSD at least. I think everybody's fairly clear that that's the mental health lane. You know, and if you have PTSD and have specialty care needs, that you would go to specialty care mental health. If you have TBI and have specialty care needs or don't, what lane are you in and who's responsible? That's a huge problem.
Yep.
But 20 years ago, it was the same thing for PTSD.
There you go. Yeah.
So I just wanted to comment on the comment made earlier about basically clinical utility. I think we, in addition to the data scientists that I strongly advocate for joining our efforts here, is a regulatory perspective as well. And in our PTSD RapidDX program efforts, we've distilled the biomarkers efforts into two components. One is how we look at biomarkers as a useful tool to understand disease pathology and biology and biotype the population. But on the other side, how are these biomarkers, could they be used as diagnostics tools? And the first step is to determine what is the clinical utility and context of use in which you're going to use that information. And it's interesting because unless you come in with a regulatory framework, and I know Michael's here in the audience and the FDA is here because we need to understand how are we going to develop this in that direction and build that in up front so that you don't go in and get 20 tests with no apparent utility. But I think bringing in that regulatory piece is important.
Yeah, so Mary Jo, I think this is a terrific discussion, and you're clearly an awesomist. Neologism I've never heard before. And I think this is a really important effort. But I guess I want to warn, based on other areas of medicine, other areas of neurology, that, the mapping between the symptoms and the underlying pathophysiology is likely to be very imperfect, right? That has been the case. I mean, that's been the lesson. I mean, when I started in neurology, we were all stamp collectors, right, in a way, right? We were describing symptoms, and very learned old gray-haired men were coming up with, different phenotypes based on the particular characterization of diseases that we really didn't understand.
Yeah.
And by now, with better imaging and with better genetics, we actually understand that, that was all wrong, right, and not really very useful. And at the end of the day, really the therapies, when we have effective therapies, most of the time they're directed not at that external symptom. I mean, sometimes they are, it can be effective, but most of the time the therapies we want, which are disease-modifying therapies, are directed at the pathophysiology or at the endophenotype that's going on. See, I got it in one more time.
I was waiting.
But
okay.
I think it really gets to an important issue, right? That this is important. Obviously, this is what the patients are coming in complaining about, is what we got to address. But ultimately, if we're ever going to develop disease-modifying therapies, we're going to understand what's going on internally, because that's what the treatments are usually directed at.
Do you think that it would be helpful as we're doing that to have this connection amongst the groups?
Oh, absolutely.
I mean, I think that's the way we have to do it. I agree with you, because to be stamp collectors is fun, but doesn't do a whole lot. Yeah.
There is a fear of, like, back to Don's point of over-testing. It was there's a great study that showed that it was around 1915 where you were finally better off seeing a physician than worse off. And so we want to kind of keep with that first do no harm and maybe not poke and prod like crazy, and have something that's really a very useful diagnostic.
I was told it's time for clinical trial design, so I'm going to have a little audience participation. So I'd like, just raise your hand, and I know Stuart, who does fund some of my work, is in the room, so just close your ears at this point. But who's run a single-site human subjects trial? Raise your hand. Okay, great, keep them up. So who's run a multi-site? Keep them up if you've been multi-site. Okay, these people right here are the people that know everything crazy that can happen in your human subjects trials, right? And I'm sure over a beverage, each of us could come up with a story that is not our lab's finest moments, things we would do differently, institutional knowledge about how to collect data. And when we have individuals starting from scratch every time, or we have to create infrastructure, so there's the things that don't go right, and then there's the things that really go right. And individuals who are working in isolation have to recreate the wheel every time. So one thing we really thought about was, how do we help create infrastructure for a clinical trials network, similar to StrokeNet, that could actually help us move the science along more quickly. This kind of infrastructure can support things from design to recruitment to data collection and harmonization across sites. And how do we start to really create infrastructure so that we don't have to repeat and recreate these things every time. The next thing we thought about was, how do we improve the knowledge gap gained during phase 2 research so it's more applicable to actually phase 3 trials. We talked at length about how to perhaps have these trials run in tandem, so you're trying one or more things at a time. How do you also get this information out there? We talked about that, so things that don't go well, we don't have to redo those again and again. And then really creating these and getting funding to create these in a way that they can really inform phase 3 trials. I think sometimes if something has been proven once, to get funding to replicate something or get funding to look at something in just slightly a different way, that innovation portion of your grant can be very, very hard to write. But how do we start to value replication and exploration as much as we do innovation sometimes? Rather than treating TBI as a homogeneous disease, developing specific outcome measures for specific domains, trying to take a precision medicine focus. And this, again, does relate to, which I think is the last one, and I'll go back, this does relate to how do we actually meet patients where they are and meet their needs. And I do really value this disease-modifying versus symptom-modifying discussion. I think, can we hold both of those simultaneously? and try to really meet patients where they are. I mentioned yesterday in our group that we just finished a PCORI-funded trial where we had individuals living with TBI, moderate to severe TBI, create their own research agenda. And I can tell you it probably doesn't look like the research agenda of some people in this room. It's very different and very focused on how do I live day to day, how do I create meaning in my life day to day while I have a brain injury. And certainly all of them love the idea of a cure, but they do need to live their lives for the next 5, 10, 15, 20 years till we do find the cure. And so how do we hold both of those? Certainly improving post hoc analyses of clinical trials. And this goes back to the idea of how do we make best use of all the data we have, how do we make use of negative trial data, and how do we combine data. In terms of, just one more thing about the precision medicine, how do we start to think about, as they do maybe in oncology better than we do, that things look very, in some ways very the same, in some ways very different, but really prescribing things for patients based upon phenotypes and endophenotypes that they come in with. And I think, anybody else from our group, was that what we talked about? Good, Grant was our fearless leader, so he gave me a thumbs up.
Fearful leader.
Yes.
Is the problem that we're teaming with tension here? Something.
Stuart.
Yeah, I think, if you could put the last slide back up.
Oh, sorry.
Oh.
Okay.
Go back. There we go.
Yeah, I think that infrastructure, I sort of alluded to that yesterday. One aspect of Sensi is that population has been recruited, they've been characterized, they've been phenotyped in many ways, or in the process of being phenotyped. And, it's an expensive undertaking. But one of the other aspects is that it's a reservoir, it's a population that could be accessible to clinical trials. And if you're looking at the chronic condition, the only problem is some of these chronic conditions, like TBI in its development, the actual study may be like Framingham, where the study has outlived many of its original investigators. But having that reservoir and that structure can make some of these things go a lot better. So maybe a civilian version, I don't know if Pat's here, but volunteering him, but having some sort of similar for the civilian population too.
I don't know if this is working. Excellent. Okay, so thank you everybody for summarizing what was going on in each of your rooms. We have kind of distilled, there are many gaps discussed last night in our leadership session as we were going through those conversations, and you heard about them here today. And so the major themes were timing. So what is that, like Jessica was bringing up, the age of the injury, what's the inter-trauma interval, what is happening when you're collecting data, so what time points are you collecting your data. And then we heard a lot, we categorized as rigor, and so basically thinking about our designs or our outcomes and how can we make these more measurable or comprehensive. And then there was a lot around the data standardization and harmonization, so you'll hear a lot about that conversation in each of your breakout rooms. Then again, we landed here at the end of this conversation with being patient and subject-centric. So beyond patients, we also have animal subjects, and we have our patient-centered outcomes that we're looking at, but really thinking about what is what is their high priority. And then again, reiterating a little bit about what Magali had mentioned in her comment leading into this, which is as we go into our breakout sessions and we're thinking about solutions, we think beyond the science. What can we do with infrastructure? What can we do with policy? What can we do with really trying to think about these cross segments, cross-sector opportunities. And I think, again, our panelists have done an excellent job at highlighting each of these themes and kind of finding ways to bridge a lot of those gaps. So just a quick note, what was so great about these breakout sessions was the openness of this conversation, the engaging of each of you in those conversations. And so there was a request during the leadership session to have some continuity from yesterday to today. And so what we've done is you had a group, a day 2 group where we had mixed you up. However, if you would like to stay with the group that you were with yesterday, please do stay and continue that conversation. I know especially some of the sessions had already gone into thinking about those solutions and would really like to spend today refining and defining those deliverables. So the leadership from preclinical, Fiona, Doug, Susanna, Pat, and Chantel will be in the preclinical room, which will be also the group 1 room. And then the phenotypes group led by Jam, MJ, and Lee will be in the phenotypes room again and the group 2 room. Biomarkers, Jessica, Lisa, Ina, Kim, and Rajiv, they'll maintain that room. And then clinical trial design led by Grant, Lisa, Dawn, David, and Terry will be in that same room. So if you would like to continue the conversation that you were having yesterday and continue supporting that brainstorming session, go back to your room. If you would like to mix it up, there is the opportunity to do that. And I think that, do we have any other notes about the breakout?
That they also have the option to go, they can choose whichever one. Yeah.
Okay, all right, excellent. And then I just want to thank all of you again. This was fantastic conversation.